Alrighty, we are here with Ben Lamm, founder and CEO of Colossal or Colossal Biosciences. And as you can tell from the name, if you're not familiar with the company, doing pretty cool. I don't know the right term, historic, prehistoric, Jurassic. We're not going to get into all that sort of stuff, but de-extinction, that word comes up a lot. Ben, unbelievable what you're doing. Pretty pinching myself moment speaking with you. Thanks for joining. How you doing today?
Yeah, I'm good. I'm good. Thanks so much for having me.
Yeah, of course, of course. When you hear about like your bio, you expect to be speaking to someone who's like 300 years old with a beard down to their toes, and we come here and it's our pre-chat was just the most casual thing I've ever interacted with. So I love your easygoing nature. But before we get to Colossal, so diving right into the what many people hope to achieve in the entrepreneurship world. So you've been part of 5 different exits, kind of some of them pretty cool scale there.
Yeah.
What
No, I'm
what
trying. I
what,
was
what do
trying
you,
to count. Like,
yeah, that well, that was just on your LinkedIn. So
yeah. Okay.
so
Great.
you
Yeah.
need to
Go off.
update your
Go off.
LinkedIn up.
Go with that. I don't know if it's fully even updated, but yeah, great.
Yeah, exactly. At least 5 exits as we're speaking. But what do you think has been what has like allowed you to lead the charge on actually successfully exiting companies?
So I think kind of threefold. I'm really curious and I like to learn new things, but and I'm very passionate about technology. So they've mostly been in like software and a little bit of space hardware, but mostly software. And then before now jumping to genetics and genetic engineering. It's just a different kind of software, I guess. But I've been very curious, which I think is a big driver. I think a second thing is I love asking questions, and the best way to get good answers is to hire industry experts that are way smarter than you in the category. So everyone always says, "Oh, you should hire people that are smarter than you," and I think that really sunk in to me at some point. And so I've been lucky to have just great women and men run these teams and kind of like really teach me along the way, which has been great. And I will say from an exit perspective, you know. Because I'm so curious and I have ADD, it's like, oh, someone wants to buy this. It's interesting. It's economically good for a lot of people, our shareholders, our employees, our investors. And so selling them was always just, I guess I just assumed it would always happen. But I never yet got to something as great as to me where I felt as passionate as Colossal. And so, so to be clear, I'm not selling Colossal. But it is
I
something
was going to buy it in this
that,
call. That was the point of this.
yeah, you're like I am Satoshi and I'm going to buy it right now. The no, but it is something that like I do think it's easier to sell things if you're in love with the process and you're in love with the building, but you don't necessarily like in love like I think some people must be in love with software, right? Because we have a lot of it on this planet. I thought it was interesting. It was systems models. I understood it and I'd build businesses around software, but never like I didn't wake up every day and say, "Oh my gosh, I'm so excited to build software." And but what's great is I've now found the that with Colossal, and so now I kind of get the best of both worlds of the building, which I love, and the entrepreneurial side, and the whole building a successful business, but also in a category that I just think is the coolest thing on the planet.
And before we get to that coolest thing on the planet, so you hear so many stories about entrepreneurs who have like a big exit and then they kind of are retired or semi-retired and they're kind of like, you know what, that was kind of my crowning achievement in the business world. What is it besides the curiosity aspect, which you already hinted at? What is it besides that keeps you coming back and being like, there's more companies that I kind of want to scratch my itch here?
Well, it's interest. Like I don't have a lot of hobbies, so I don't know. I mean, I get bored easy, so it's like I don't know what you would do, right? Like I hear those stories too, right? And maybe I'm just like really jealous of those people that can be like, I'm excited to do nothing, and it's like that sounds crazy to me. Like being alone with my own thoughts just maybe like that's like prison in itself, right? So I don't want that. I need to keep moving and keep swimming, right? So for me, I think that the journey is way more interesting than an exit or a destination. But there are people that love that destination, and I don't understand them. But that's good for them. They're happy. I'm happy for them.
So let's get to Colossal, and this is extra surreal because I mean, many this might have been over 200 episodes ago now, but we had an entrepreneur named Betty Brennan on, which I'm sure I was able to pronounce her name at the time. I don't know what happened over those episodes, but she has since sold her business. But she used to work in the space where they would make like models and figures for museums, like museum displays.
Yeah.
And the one quote I remember, one of my favorite quotes of any guest, she's just like, who wouldn't want to build woolly mammoths? Like she literally would build woolly mammoths and
Yeah.
put them in museums, like statues, figurines, and
That's how
stuff.
I feel. Betty and I feel the same.
Yeah, exactly. So now you've taken that childlike curiosity that Betty has, and you have, let's just say, you're going a bit farther than building animatronic woolly mammoths here.
Yeah.
So Colossal, for anybody that's not familiar with, now obviously there's a ton online you can read about, but like if you had to put Colossal down into like one line or one, tiny statement, why does Colossal exist?
So Colossal exists because the world needs a de-extinction species preservation company because we are in the sixth mass extinction.
Man, we should just end the end the podcast there. That's quite the mic
All right,
drop.
yeah,
All
we'll
right,
be done.
so yeah, so
All right.
add some more detail there. So mass extinction.
Yeah.
What's that?
Yeah.
What's that actually look like?
So the world's gone through a bunch of different extinction events, right? But this one is human caused, right? And so, if you look at kind of all of the extinction rates out there, it's forecasted that we could lose half of biodiversity in the next 25 years, right? And some people argue it's like, oh, no, it could be 40. Okay, great, 40. So in the next, reasonable time period, we could lose half of it. The current trend line is half of biodiversity on Earth, right? And so I believe that that tells us something. That tells us that modern conservation, while it works, isn't working fast enough. So it's like, what can we do? Coming from software, coming from other things, systems designs, we probably need redundancy systems, right? So how do we think about that? And then we need kind of fail-safe systems, right? And so when you think about that, the way that we decided to put Colossal to solve, to make sure that like we could help accelerate conservation, build redundancy, and also build fail-safes was, all the technology that we build on this path to bring back these species, we can open source to conservation, which we do, and we also launched a foundation with a separate $100 million of capital, and so we could do that, which we thought was a good idea. Secondly, we could work with governments all over the world. We just launched our first one in Dubai and build bio vaults, right? So like super biobanking, where you're banking cells, doing genomics on the cells, understanding population diversity, understanding genetics, bottleneck, inbreeding, understanding all that about so that you can understand not just to preserve the species, but understand the health of the species, right? And so that you have kind of this like living Noah's Ark 2.0, right? And then the third is, a de-extinction toolkit, right? Where you could either clone endangered species, clone extinct species if you had cells like a recent extinction, or rebuild an entire extinct species like the woolly mammoth or the dodo. And so those three things together, we felt wasn't represented in the world in any meaningful way. And so you hear that, you hear these crazy stats about loss of biodiversity and climate change and all these ecosystem restoration projects that aren't working. And you're like, okay, maybe we can do something. And so that was how we kind of wanted to go tackle this problem.
And so we'll talk about plenty of the different animals slash projects. I don't know what the official name you have it for your focuses, but woolly mammoth, for example, obviously there's so much coolness and energy, and they're just such like the coolest looking things ever.
Yeah, there's not like Facebook hate groups around woolly mammoths right now.
Yeah,
a lot of people,
as far as we know, there probably is. No.
They're probably a handful, but not many, right? Compared to everything else,
Yeah.
right?
But what about in terms of climate and the environment? What if let's say there's some woolly mammoths that are like back and like real living, breathing things? What can that help do
Well,
for
that's
the
our plan.
environment?
So yeah, let's assume success. We don't even have to be hypothetical. Let's just assume success. But a lot of times people, and what's interesting about all these projects is there's opportunities for education. And to your point, there's so many people that are excited and lean in. And literally every week we get hundreds of like letters from teachers and parents and kids and little drawings of mammoths and stuff like that, which is awesome. and it's super rewarding, right? But it also leads to some questions, right? Like, why do this, and which we talked a little bit about a second ago. But it's also like, but weren't everyone's seen like Ray Romano in like Ice Age, right? And so they're all like, oh no, like it's all just freezing. But what it also creates an opportunity to explain that right now we're in the Holocene, but before that was the Pleistocene era when mammoths really thrived. And there were periods in that. Most people think of that as just Ice Age, right? Like the movie, but there were these interglacial periods were actually warmer than today. And if you look at migratory patterns of mammoths and the nature of those periods, they were many mammoth species were also like in warmer environments than today and had vast migratory patterns. And so what's interesting is that the core ecosystem where we want to return them, being the tundra, which is a part of the Arctic Circle, and then Circle Polar North, which is a little bit bigger from a latitude perspective. It's that ecosystem still exists, but it's massively degraded. And there's been scientists all over the world that have done ecosystem restoration modeling to show that if you could reintroduce a cold tolerant a species back, like a mammoth, back into that environment at the right scale, the right numbers of sustainable biodiversity herds, well, then you could actually have a meaningful impact on, jump starting that kind of ancestral heartbeat of that ecosystem. And so we think that's awesome and exciting. And that's just one of the many reasons why we wanted to do the mammoth.
So there's like I mean, it's all pretty mind blowing to hear about, but like the technology side of things, when in your mind was the world ready, or I mean, if it is, for this type of thing and like de-extinction to happen in this scale?
When we started the business, like the core technologies and discoveries had been made, right? Like you had things like AI, some access to compute, discoveries like CRISPR and other genome engineering tools, right? But there's still entire categories like assisted reproductive technologies for like elephants that like no one's ever studied. But what's interesting about the project from day one is that, even with the technologies of yesterday, like, 4 years ago, which seems like a lifetime from kind of where we're sitting, is all the technologies existed. So it's not like we needed to invent like faster than light travel or wait for quantum to eventually get here scale where we could make this happen, right? Like all the technologies that we needed existed, right? Kind of like think about like the iPhone. Like all the technologies existed. Now they innovated and they invented new technologies to make the iPhone better, but things like the Palm Pilot and things like phones and Nokia and all those things existed before the iPhone, right? Software and software systems and app stores existed before. And it was really that innovation and invention and iteration on these things that made the iPhone, right? On day one. And so that's a lot like Colossal, right? And so with just the right expertise, the right technologies, and the right focus and funding, we knew we could be successful. What we have found, though, and what we assume from day one, so we're pretty happy that this has come true, is that with additional access to compute, with the proliferation of newer models in AI, with abilities to look at sequencing even deeper and faster, and as some of that democratization happens and gets cheaper, well, you get things that are cheaper and faster, right? And so we are able to then push the boundaries of the most innovative technologies while we're not having to spend as much time or money or focus on the technologies that are now just table stakes. And so that was an assumption we made from day one, and we're glad it's proving true. So that curve of what is possible, becomes exponential much faster than a linear model without kind of that exponential technology component.
So I'm curious about the scientific and tech side of it. And I'm somebody who's curious in everything. So like
Oh, same,
you
same, same.
could get as
Yeah.
granular as you want and I'd still be interested, but I also probably wouldn't understand it at all unless
I'm not a
unless we
scientist,
had a
so
huge amount of time. Yeah.
everything I know about science is because I have like really smart people around me that I get to ask questions to all the time.
Yeah,
So
yeah. So I
yeah,
guess like in its highest level to start, how does it work? Like
yeah,
what
great
you're
question.
what you're going for with everything, how does it work?
Yeah, so the highest level process is we have to go find ancient DNA. Sometimes researchers have already done it and they have the sequence, right? And they sequence that DNA. Sometimes we have to go work with museums. Sometimes we work with private collectors that have samples and bones, right? Sometimes we actually do expeditions, or we work with partners like the Explorers Club that have a network of explorers that go out into the field, right? And you have to get samples, however you get those samples. And I kind of give it a few examples. Well, then you have to drill those samples, right? And you have to go through a process of like looking for ancient DNA. And what's crazy about ancient DNA is DNA degrades very, very quickly. And so you can be drilling on a bone right here and get nothing, right? And then you can literally go like 3 inches over, and because of the density and how the bone is positioned or whatever, you can like hit the jackpot and get great DNA. And so when you go through that process, right, you have to collect those samples. And then you have to sequence it, right? And the more DNA samples that we can get, the higher likelihood that we can build a genome or near complete genome. And so, the more reads of the genome you can get and the more samples, the better, because it is a destructive sampling process. And so once you get your ancient genomes, right, and you then do comparative genomics, one of the things that we continually find interesting is that some of the species, like we think, oh, this species is closely related to this. It actually just isn't. And we're just wrong as humans, and it's okay because it's science and you can find new data, right? And so you then look at the comparative genomics to figure out which animals these are the closest living relatives to. And then you do a lot of comparative genomics to understand how they're similar, how they're different. And then that gives you some ideas of where you want to go deeper to do further analysis and testing so that you can then pick what you want to edit. And then you use that closest living relatives cell, which is the genetic donor cell, right? Because you can't clone from a non-living cell if you just have data, right? And then you take that computational analysis, you then use a combination of editing tools to make changes in the data. Sometimes it's individual changes. Sometimes it's one change. Sometimes it's a big block of changes. Sometimes you're knocking something out of the DNA. So there's all these different tools that people will use and that we use to deliver those edits to the cells. And then once you get that, there's a lot of testing and verification that I'm skipping through. But once you get to those cells, you do the process that made Dolly the sheep, which is called cloning, where you take the nucleus of one of those cells, put it into that of an egg cell, and then you use assisted reproductive technologies like IVF to put that into that genetic donor surrogate. And if all goes well at whatever period of gestation that specific animal has, you get your animal.
It is so cool. Like,
no, it's pretty cool. Like it's pretty cool. And if you want to get weirder, we also have a 17-person team working on artificial wombs. Everything from like avian artificial egg constructs to placental interfaces. And so so we have a separate, because our long-term goal from a productionization perspective of endangered species is that we want to have artificial wombs so that you don't even have to use the surrogacy part. And then you can get mass scale, right? Because you can use a lot of donor cells for genetic donor. You can engineer in synthetic diversity into the cells themselves, in addition to different genetic donor cell lines. And then you could grow them all ex utero. So imagine a world where you've got warehouse labs full of mammoths growing in artificial wombs, and that's our vision. Like that's our vision, but also it directly applies to some of the healthcare applications as well as for endangered species.
So you made well. I guess to go back, like if somebody's looking high level at Colossal, so like I think the key term is like ancient DNA. It kind of all starts there, and that's so cool in itself. I know you hear the Jurassic Park comparisons all the time. I'm not going to hit you on the face with that.
We have heard that.
But I think it's really cool that you're living like there's some Severance in there. There's some Indiana Jones. There's some Ross from Friends.
It is definitely a mashup for sure.
You guys made a ton of headlines with the dire wolf.
Mm-hmm.
What is how exactly similar is that dire wolf compared to its family or friends or cousin, whatever you want to call it, from thousands of years ago?
Are over 99% the same as gray wolves, right? And many people thought they were closer related to jackals because they just didn't have a lot of data at the time, and the data they had mapped closer to jackals. Then when we got more genomes, we actually showed, nope, that was incorrect. That's okay. That's science. they're actually closer related to gray wolves, and they're actually very, very closely related to gray wolves, right? And so, over 99% the same. And then what we did is then we focused. We were very lucky, to be honest, because we had two genomes that we got great coverage on, and we got a lot of the genome, and they had 60,000 years of genetic divergence, and they were from two completely different areas. And so what was amazing about that is, there's more time between our two dire wolf samples than our second sample and today's wolves. So it was really cool, right? Because that's only 12,000, 13,000 years, and this was 60,000 years, which is pretty cool. And so we think it's pretty cool, at least. And so that allowed us to really hone in what were the genes that were conserved and that really made a dire wolf unique. In that 60,000 years of genetic divergence, what was conserved and protected to keep them dire wolves, and then how closely did that map to that of the gray wolf? And what we found is, and we kind of assumed this from bones and morphology, is that they were 20% bigger, therefore, and based on their bone density, we would assume they were heavier and stronger. They were in a Pleistocene wolf, and based on the different time periods that they existed, we thought they would probably be white. We assumed their fur would be a certain thickness, right? But you don't have any of that in the fossil record, right? And so as we did further analysis on the genome, we actually did understand that they were white. We did understand a lot of things, but the genome's not going to tell you what the coat's going to feel like, right? Or what their babies are going to look like. And when they were born, they almost look like little baby pandas. They were ridiculous and amazing. And so we did all that work, and then we engineered in those core things that really made a dire wolf. And fast forward the clock, our two boys are over 125 pounds. They're doing great. They're now starting to hunt on their own, which is pretty awesome in the ecological preserve we have them in. And it's pretty great.
Congrats on that. I already know you're a proud father. Now you're a proud father in many, many ways. But
it's pretty cool. I have a strange couple of puppies.
All right, last thing real quick on Colossal. So obviously the big, well, it sounds funny in this context, but the white whale is the woolly mammoth. So what, in your mind, what needs to happen? What's the key thing that needs to unlock in order to, de-extinct and bring back the woolly mammoth?
So we're in the process, right? And so there's no science gates, right? And we try to parallel path things from a systems model perspective. So we try to work on all these different paths at the same time. So we're in the editing phase. We've already done, we have over 100 mammoth genomes across 1.4 million years of genetic divergence. It's informed our targeting from a computational biology perspective, our target editing, and then we've actually been editing the cell lines for a couple of different cell lines for Asian elephants for now several years, which is great. I'd say that we're on track right now to have the editing wrapped up this year and have hopefully our embryos this year. And then separately, we've been working on effectively, I think of it as like IVF in elephants, and in that. We want to have successful transfers of those embryos into surrogates, right? And so that's a process that our animal operations and animal welfare team have been working on now for several years, right? And so we don't wait to get to a certain milestone before we continue. We try to parallel path everything. So everything's known that we need to do. We're just going through the motions right now, and we have about, the mammoth team's like 35 people. It's either 35 or 40. It's our largest single species team. But it's our flagship project, right? And so we've got all these other cool things going on, some of which we've announced, some of which we haven't. And that is that's definitely for me and for George, it's probably our biggest flagship project.
In George Church, for those who are wondering,
it's
George or George Harrison. But
I don't think it's our hardest project either. I think it's a very hard project, but we have some other things that we're working on that are older that I think are hard.
Well, for my short time after college in the corporate world, I remember the term "big, hairy, audacious goals," and you're bringing new meaning to big,
Yes,
hairy,
yes, we are. I
audacious
actually
goals.
said
So,
that. We have this big, hairy, audacious goal to bring back the mammoth in the next few years. So yeah.
all right. Well, I know you got to run soon. Let's wrap up with some rapid fire Q&A real quick. You ready for it?
Okay, great. Yeah, go for it.
All right. Let's get wild and hairy and woolly. Uh, what is something that you've learned about genetics or just DNA in general that most people would be shocked to hear?
It's weird. I understand it's not magic, it's science, but it kind of feels like magic. Like these little individual, like I mean, these chemical, they want to work together, and so like they're it's like magnets. They like come back together. It's not like you break something and then you're just like, oh no, how do I put it back together? Right? There is. I believe there's a true intentionality even at the molecular level of life, and and that's pretty awesome. And we see that in the lab, like and some and like and you even see this in evolution where things like that are bad will kind of edit themselves out. It's pretty magical.
It is, and I'm laughing for those watching on a video. We're trying to teach our daughter some, in a daycare. They're trying to teach her some of the sign language now, and the sign for more is what
Yes,
exactly what Ben just did
yes,
with
yes.
his hands about DNA. So no, it's really cool. It is magical. All right, what is the let's say all goes well with Woolly Mammoth. You're really happy with everything. It's kind of obviously crowning achievement as a company. What's like? Is there any animal kind of beyond the woolly mammoth that you're
Oh,
like
there's
that
so
would
many
be?
animals.
Yeah.
There's so many animals. Me people won't think it's cool, but I think the stellar sea cow is beyond the mammoth, right? We can't grow them because the babies are bigger than existing manatees or dugongs. But think of it like a whale-sized manatee. Like sounds awesome and sounds nice and awesome and docile. Yeah. So like I think it'd be cool. And but you can't grow them because there's nothing to gestate them in. So.
Oh my god, yeah. We have a lot of picture googling to look up after this. All right, and then last one. This is the hardest one you'll ever answer. I saw you studied accounting in college. What would your college age accounting studying self think of what you're doing right now?
Yeah. So it's finance and accounting, and I think they would be like, "Thank God," because you hated this shit in college. So yeah,
Yeah, a lot of people have great careers in accounting, and a lot of people are
yeah.
like,
But it
nope.
just wasn't for me, right? Like it taught me a lot about balance sheets and finance and investing, but it just wasn't for me.
Yeah. Well, I appreciate that you made the jump. You're up to some pretty cool things. So, Ben, thank you so much. I know if anybody wants to learn more about Colossal, they can do so at colossal.com. Ben, you're on LinkedIn. Anywhere else you want to shout out?
I mean, we're on X, we're on everything. So whatever people want to follow us, we're around.
Awesome. And last final words, just some final thoughts. Close this down any way you want at this stage is yours.
Look, we are in an extinction crisis. I'll go back to the beginning. We're in an extinction crisis, and a lot of times we get preached, doom and gloom, and we only hear about the negative on this 24-hour news cycle. But like, I'm a big optimist. I'm a believer in hope, and we are seeing like tremendous applications to our technologies today for conservation, and it's really the next generation. And I think we're doing a lot to hopefully inspire them and do things the best way we can. We're going to screw up a lot of things along the way, but we're doing the best we can we're at least trying. And I just have while you hear these extinction stats and whatnot, I'm very very hopeful about the future because I do think that we can out innovate what we've done.
Bring on the bongos.